So now let's review how to use combined facet bodies in practice. We set the scene by using a car body, where the body is formed by individual convergent bodies, separated at planar cuts and that are to be combined into single resulting body. We will also be looking closer to a couple of examples of the rear bumper that have been scanned from several views, where the convergent bodies are to be combined. Depending on the input, there are some guidelines I would like to share with you here. We start by combining the separate convergent bodies of the main car body into one. To do so, we evoke the combine facetted bodies function and add all the separate bodies to our selection. As the bodies selected contain a considerable amount of facets, the system returns an alert message for a very high number of facets in the resulting body. To optimize, you therefore have the option to set the average size to reduce the number of facets in the resulting body by increasing the average facet size. Using the average facet size, you can also fill holes, should you require. In the creation process of the combined body, you have the option to hide, keep, or delete the input bodies, which can speed up your process depending on your requirements or preference. In addition, you of course have the option to evaluate the resulting body on the fly by using the Analyze Mesh quality that immediately provide you with a report. Convenient to help you decide for the next step of the resulting body, depending on the downstream purpose. For more details on the quality of a convergent body, you have the Cleanup Facet Body option. Executing the Cleanup Facet Body on the combined body we just created reveals the issues that can come to cause problems downstream if left unattended. For now, however, we will leave them as is and return to dealing with them in the later bumper example. Before exiting the analyze, however, please note that the issues are located around the seams or planar cuts of the individual bodies before combining them. We now turn to the bumper area for a more detailed look, as this is a more isolated area and easier to use as a showcase. For this merge, we see that the two bodies of the bumper to be combined, the right yellow and the left green, are overlapping heavily. The optimal situation here would be for the bodies to not overlap too much. The Analyze on the fly will provide a report on the result, and we can see that the result is of a medium quality. To demonstrate a more optimized situation, we have prepared another scan of the bumper. Here we can see that the overlap is way less, and also note that the result of the combined body is graded to good quality. To further and in more detail assess the quality of the resulting body, we run the Cleanup Facet Body, turn on all the Analyze option and assess the result. We note that the potential issues reside in the overlapping area. For yet further understanding, we turn on the Show Facet Edges and zoom into the areas with the potential issues. We note that the triangulation of the facets might not be optimal in the overlapping area, hence the result of the analyze. To optimize the resulting body for downstream use, there is a great tool in Ramesh. Here we set the mode to variable to reduce facets in areas with less curvature. We also remove the lock to the sharp edges by setting the sharp edges to no lock. Reducing the tolerance will help to keep the shape if necessary. We also remove the lock boundary and reduce the tolerance should the shape need to be followed somewhat more precise. Executing the remesh and studying the result reveals a very nice optimized mesh with less amount of facets, a great input for further downstream purposes. This concludes the practical demonstration around combined facet bodies, and I'm sure you see some really great use of this new functionality.